Hello, everyone. Welcome to this week's episode of ClueCon Weekly. Joining us this week is Dave Taht from nowhere else than Starbase, Texas, for the StarX launch, and Herbert Wolverson from LibreQoS. And last time we met, Dave walked us through what the Bufferbloat was and what the various algorithms to resolve. And we're going to take a look at how that work in that direction has moved and what they've been doing. It's a very interesting problem that affects almost all network traffic. And frankly, before we met the first time, I didn't even know it existed. So thank you for joining us again today, Dave.
Thank you very much for having me on the show. I'm the co-founder of the Bufferbloat project with Jim Geddes, who is no longer allowed to mention the B word, but occasionally I hear from him in my head saying hi there. Anyway, but we're here in Starbase, Texas to do something completely different, which is the watch Starship launch, the biggest rocket ever built by anyone. And unfortunately, this morning there was a scrub. So darn, I had to do a podcast with you instead. Also with us today is Herbert Wolverson, who is, well, introduce yourself, Herbert, please.
Hi, I'm Herbert Wolverson. I'm the author of the Rust book, Hands on Rust, and also Rust Brain Teasers. I also work for a wireless ISP in central Missouri. And when I'm not doing any of that, I run around chasing after a toddler. I came to this project originally because we really liked the early stages of LibreQoS. It really helped my network start to run better. So being the coder and general geek that I am, I dived in, spotted a couple of issues that needed to be fixed on the Linux kernel side and went and fixed them. Then I kind of got hooked, and for the last few months, I've been plugging in more and more code to visualize what's going on with people's networks and also connect the shaping system to to your network. Try to come up with a good way to install the thing that doesn't require a PhD, come up with a good management interface to use the thing, and give you a good way to actually see that it's helping you, so that more and more people will use it and hopefully de-bloat their connections and start to speed up their ISPs.
Nice. So yeah, why don't we take a look? I see a lot of interesting graphs going on there. So maybe we can start by explaining what the Bufferbloat problem is and what the solutions are and go from there.
Cool. So could you grow the screen to be full size? I've been working on network technologies my entire life, and until Herbert started coming up with these visualizations, I saw these kind of patterns in my head. And this is what's really happening underneath on everybody's internet connections. Here we're running a bunch of tests through our test bed today, trying to demonstrate what a 25 megabit, 3 megabit link actually looks like. And I'm not really prepared to talk to the pictures because I was just about to talk to that picture before it vanished. But the Bufferbloat, there we go. See that lump there on Q-Link? You see that big bump? That's called slow start. Okay? When a TCP connection first starts up, it has this huge ramp where it tries to find the bandwidth, and then it settles down, ideally, to a steady state, like you see here. So in this case, I'm doing an upload on a 3 megabit link using the AQM with a rough average of about 2 packets outstanding in buffering. And that is close to being the right number. The Bufferbloat problem itself, though, started when we realized that most of our devices had 100 packets or even 1,000 packets of buffering, which caused enormous latency spikes and made video conferencing calls like this nearly impossible. So 14 years ago, Jim Geddes and I set out to fix this and proved how to fix it in 2012, and it's taken a really long time for the fixes to propagate. And about a year ago now, I guess, I started joining the LibreQoS project like Herbert did, and then finding a way of making really good high-speed, low-latency technology just work at the same time as everything else. And my original plan was that I would try to upgrade all the devices in the world, billions of devices, to the FQ-CODL and CAKE algorithms. Aha! So we just saw 2 flows start simultaneously, both of them in slow start.
Mhm.
And then they settled down. And because I'm doing a 25 megabit thing here, I ended up with 200 packets outstanding, which is the right number for that. And it settled down to about 100. And you can see these little spikes on the delays side showing us how much delay is happening for each of these different kinds of flows.
Yeah.
And while I'm talking to this, you're going to see that we have two different colors now. This is exciting. We have two different kinds of flows happening at the same time. And this is honest to God. It's like, for me as a computer scientist, it's like being able to wander around like a physicist on the edges of the atom
Oh,
and
yeah.
see it in real time. And so for me, and for Herbert, we say, wow, so that's what the network really looks like. That's what voice really looks like. And I don't know how to, is this what it looked like to you before the call? What does the internet look like to you, sir, our host today?
Well, yeah. I mean, the concept of, so I'm an application developer. So to me, I'm generally living in application world, meaning that I just attribute the any latency or any issues to the gods of the network, and I just it's just how it works for me. But in general, yeah, it is. Of course, jokes aside, it's very important because this is where. So for the people who are looking at this is where your jitter comes from, your lower quality invoice call comes from. Because when you're trying to reconstruct a download, even if packets arrive late or out of order, it will be slower, but you will have the file. Well, if you're listening I mean, it's a phone call, you're listening to some streaming audio, whatever. If a packet comes late or it's lost, it's just gone. It's just it will won't come back. It's a hole in the audio you're hearing, and that needs to be reconstructed and rebuilt for. So yeah, there's a lot. There's a lot to go about. It's just amazing to look at it. Cool. So, how can someone take advantage of this knowledge? Now that we know, you need to update your network devices. What if you're running in the cloud? Does this affect you? That's the kind of question.
Herbert?
Well, what we're focusing on right now is a setup for ISPs. So you install it between your internet connection and your customers, and it will apply this technology automatically on the way through. So it's and the phrase we usually use is a bump in the wire. That way you can set up, one big box for a really big connection, or we work with a lot of smaller wireless ISPs who really benefit from this because wireless is the domain of variable latency. Um, and for something like that, you can install this. It's free software. You can put it on a relatively modest server
Mhm.
and see pretty much instant improvement in your network. We try and integrate with a bunch of the more popular CRM systems so that it knows that Joe Blogs at this IP address should have this plan, and apply that for you if you want, or you can put them in yourself. Uh, and even if you don't put plans in, you start seeing an immediate benefit because it just starts to smooth out all of the flows relative to one another. So you can really just open the box, put it in, tell it which network ports are facing the internet and your network and how much bandwidth you have in total, and you'll see some improvement right away. But obviously, it really starts to benefit from knowing a bit more about your network. We um, if you want to start getting into the depths of things, we do support hierarchies. So if you've, say, got a link
Mhm.
on your network with people behind it, and that link is full, you can tell the shaper box that that link is there, who's behind it, and how much capacity it has. And so it will optimize them almost separately to try and squish them down into what your link's capable of doing. So on that front, it saves you some money. On the other front, it saves you customers because we installed this and pretty much stopped getting calls about my network feels slow. Um, customers, um, maybe 1% of our customers run speed tests regularly and call us to beat us about the result. But 99% of the time, what they want is for it to feel good. They start a video, the video plays, it's smooth. You don't get the infamous buffering screen, and that's really what this helps with. And all when COVID came along, everybody started working from home. Um, LibreQoS made an enormous difference in terms of the quality of people's Zoom calls into work, accessing remote cloud systems, things like that. And so I know we've got one or two brave users who've tried this at home, other than me, because I'm building it, so I run it everywhere I can.
Yeah.
It needs a little bit more effort on scaling down. We're talking about eventually trying to get down to being able to put in small boxes to help with your small home network. We're not there yet. Right now, we're trying to focus on ISPs. We've got to the point that we've flooded 25 gigs of connection, and hopefully we can talk somebody into donating a bigger connection for us to try and flood next. And Dave,
Well, you touched upon a lot of things there, Herbert, and I don't know if we're jumping ahead of the audience or not.
Well, we'll try.
Well, there's a lot of things that people don't really understand about how the network really works. And I love having visuals, but even your typical, we're emulating here a 25 megabit plan done right. And it turns out in almost all the data we've gotten from the field, we have quite a few people that are using this now. And it turns out that average usage is like 5 megabits per subscriber. Even if you have a gigabit plan, it's still 5 megabits. So finding a way to deliver low latency, low bandwidth, or fairly low bandwidth by modern standards lets us improve the outermost portions of the internet for everybody. So particularly rural ISPs and stuff like that are jumping all over this stuff. It's free software, like I said. It's like everything else I've been doing for the last decade is just convincing people that we can build a better network, can build a better internet.
Yeah, that's so what's the I was looking at the project and I was looking around a few interesting information points about LibreQoS, but what's quality experience and why is quality of experience so important, not only for
Sure.
first for people, let's put it that way, but why is it relevant in general?
For starters, there's no such thing as QoS. Classic QoS does not work across the internet. We know that. Most people didn't know that. We're not doing QoS. We called it that because that's what people want to call it. It's actually smart queue management, which is a combination of fair queuing and AQM. It's the fair queuing that helps the most on improving video conferencing and gaming experiences. It's also the hardest thing to plot. But we are able to easily show that smaller queues are better. So we could have called the company's called LibreQoE, quality of experience, and we called it product LibreQoS, and what it really is Libre Smart Queue Management. So hopefully we'll get people to think about the right things along the way to building a better experience across the internet.
Yeah, so I think the most important thing I gather from this is how ISPs are general. So ISPs and in general institutions like universities, etc., giving fair cues to people, I think it's going to be very important for empowering communities. It's kind of like we're seeing this as a completely different direction. But I've been working with a work group that does a lot of LLM. We can call it the GPT, like AI research, even if it's actually an LLM. And I feel like that's also another component that's starting to help people, because you don't need a formal education to program an LLM. You need to learn how to speak to it, etc. All of these initiatives making the internet fairer are going to be very important in the future, because we have a couple billion people who don't have access to any of this, and we need to get them on here. The quicker, the better, in my opinion.
We have another half the world left to connect, and we won't be able to connect them all at the kind of rates you can experience in a major city. But if we manage the latency properly, we can absolutely improve everyone's internet experience to where we can use tools like these.
So can I just I can download and run this anywhere, right? This is fully open source.
Right now, it requires a Linux box. You want to have two or three network interfaces. Ideally 2, because that's by far the easier to set up, but you sickle on a stick with VLANs if you need to. And it's a really good idea to have the extra interface for managing the thing, because we spend a lot of time bypassing Linux kernel, and so if you
600 lines of code to do the core ports of this, it's the fastest. Herbert got rid of millions of lines of code in the Linux stack to make it run at 25 gigabits for 10,000 subscribers. Sorry to cut you off, but 25 gigabits, 10,000 subscribers on a box that is a 16-core Pentium, Xeon Gold. So with that tiny investment, any ISP in the world can vastly improve the quality of the internet experience with this FOSS software. I hope they all run. They can do it over a weekend. We've seen multiple people do it over a weekend now.
Yeah, that's
Could you run this
I
on a
always
Raspberry, or is it too slow?
that is actually on my list of things to play with in the future. I wouldn't try and run this version because it is very much optimized towards tracking flow data for tens of thousands of customers. So your Raspberry Pi is going to run out of RAM and make your life miserable. It should be quite possible to scale it down. I just haven't done it yet.
I have a new one right here. That's what I'm asking. I have a couple things I want to do. It's probably going to be a 3D printer controller, but why not try this first?
Cool. Well, I mean, in the other case that I've been trying till now was to try to get the cake and FQ-coddle algorithms into every device on the planet. And we've succeeded on Apple's products, and this FQ-coddle is a default in Linux now. It just hadn't made it as far as the edge where we intended it to go. So there's a lot of people in a home situation like yourself that will use a Raspberry Pi to apply smart queue management for just them. And go for it, guys. It was trying to do it for 10,000 people at a time at a low cost is what the LibreQoS project's about.
Another thing I'm thinking about, which is not very grassroots thing, because you need a carrier for that. You could run this on edge nodes on 5G.
Yes. You mentioned cloud stuff. Sorry, Herbert, I haven't really mentioned that. That's kind of a 2.0 thing. But basically the 5G networks are the most latency and jitter networks almost ever designed. And they need this stuff deeply embedded in them. But until recently, they weren't really listening. But I am thinking that with the increased amount of 5G to the home we're seeing, that the complaint level will rise to where there's suddenly demand for better, smarter queuing solutions for those too. And maybe we'll be there for them.
Well, thinking aloud, one thing that comes to mind is if you have a smarter queuing, so service is better, you need less total bandwidth to make everybody happy. So that's the real, carriers. If you're watching, this is actually saving you money. So take a look.
Not only that, your service quality, but also let me make a point to you, cellular carriers. Delays in excess of 1 second are actually far worse for you because you get all this duplicated traffic. If somehow, carriers, you can get your maximum delay below 1/4 of a second, you will definitely also save on bandwidth and have a vastly better service. Call. Operators are standing by.
Call +1-800.
Get better net.
Smart queuing. Yeah, I feel like so. The explanation is simple. If you have better overall service, the solution to your perceived lack of quality. I mean, usually right now, you think you don't have enough bandwidth. That's not true. You're not using the bandwidth correct, right? It's so having something that shapes the bandwidth correctly means that people won't have to need as much bandwidth. Now we're talking.
It's a lie.
Well,
You do not need bandwidth to make a phone call. You just need reliable low latency and jitter.
Well, that's indeed true. I mean, bandwidth is a band-aid. Of course, if you have gigabits of bandwidth, it will work, but then you're not solving anything. It's kind of like, computing. There was a period about 5 to 10 years ago, before GPUs came out and things started working better again, everything was just being sold by throwing more CPU at things or memory at things. Like I remember, I'm a Ruby developer. I remember versions of Ruby that explicitly had commands in the source code saying, we don't care about memory right now because everybody has enough. But that doesn't work for a long time. Like the bandwidth definition is similar. So, well, I'm glad I came to your same conclusion.
Well, yeah, part of why, to me, all these wonderful pictures that Herbert put up. By the way, Herbert, could you put the pictures up again? Is stuff that I was seeing in my head and trying to explain. This is how the network really works. Analogy I came up with recently in relation to COVID was that here I am with a microscope showing little microbes swimming around magically and explaining to people that these things swimming around, the germs here, are what's causing a great plague. People would think you're crazy. And yet this is honest to God, people out there. This is what a network really looks like. Could you click on all 10s? Because I want to make a big point also to the cellular people in the world. Herbert, thank you. So one of the things I've always been struggling with getting people to understand is that we need to drop packets in order to do good congestion control using all the old methods. But in 2012, we stuck a beautiful new mechanism called RFC 3168, which allows you to do congestion control without dropping packets. So here we are maintaining low latency, but instead of dropping packets, we are actually marking them to keep the queue size there under control. It's one of the huge sources of guilt that I have in seeing the deployment. One of the deployments is over 10,000 users, and they were dropping 20 million packets a day in order to get good congestion control and better internet. But those 20 million packets have a significant energy cost, and it just seems like a tragic waste. So all I've had to do is convince everybody to turn on ECN support. It's one line in all the operating systems in the world. It's one line. And with our stuff in place here, then suddenly we dropped. It keeps me awake at night, realizing how many packets we are wasting. So,
yeah, well, from a pure almost application developer viewpoint, any retransmit is a waste of energy because I shouldn't be doing that. Like I understand it's at a protocol level, but it's a lot of. And I think since we've been conscious about energy, it's really something that we need to start thinking about. Like, how can we avoid getting bad-mouthed by the press? Because right now, so it was Bitcoin for a while. For a while, Bitcoin was the worst ever. We're consuming all day energy. Today, I saw an article about how much energy an LLM like GPT needs to work. And again, it's the same size as San Francisco and blah, blah, and whatever. And next time it's just going to be networks in general because they need to find someone. And probably being conscious of that is a good PR idea. B, if you think about the planet, it's probably a good idea in general.
I also like not having to lose packets because when you're in Europe, right?
I am, yeah.
So if I can convince a couple video conferencing makers to also adopt some form of ECN, while we hopefully roll out a ton more LibreQoS, then video conferencing will improve also. So,
but
there's a lot.
So I have a question for you. Could this be rolled out? And so say I am a company building a video application and I'm not using SignalWire's APIs, but I'm building it on my own using Frizzage or whatever. Could I, as a company, use this, or does this need to live in my customers' ISPs? Because let's flip the script.
I would encourage, I would hope when you guys were saying, hey, you VoIP users out there, make sure FQCODL and Cake are on everywhere. Make sure it's on your middle boxes in your branch offices and do all that. And if not, please go install this kind of this smart bridge software everywhere else you can. So it's a matter of a rising tide would lift all boats here, Luca. I just have to raise awareness of how much better video conferencing could be if this was everywhere.
Well,
yeah, we spent quite a bit of time making sure that this runs in VMs. The idea for that being that eventually because a lot of data centers prefer a greatly containerized setup, right down
Definitely.
to software-defined networking. And so the idea eventually is that you can stick this in a container in your car. There's still a few plumbing issues to fix. There's still a few plumbing issues to figure out with that, but I'm hoping that eventually we will start to see this in a wider scale. Even just turning on FQ Cuddle or a Cake on your interfaces in your VMs makes a surprising difference. But I would recommend something like this close to your egress point, because that can really smooth out the connections that are coming in, and particularly with something like streaming video, where you've got potentially thousands of people, hopefully even more than that, customers trying to watch your videos at once. That's a lot of streams. You do a lot of load balancing, but at the same time, sooner or later, they're going to start getting buffered and queued up inside routers, and um, the routers may or may not play ball. If you can just encourage your routers to put in the protocols, that solves quite a lot of problems. But otherwise, hopefully, we can start to make an impact on that end as well.
Nice,
Isn't
nice.
it?
Yeah.
We could all start overnight. Everyone on this show, 3,000 plus people, download the Debian file, hit install, tell a friend, and we could really speed up the entire edge of the internet as fast as people could burn a weekend on it. And 14
Nice.
years.
Yeah, I think another. So, is there anything at the application level that someone could do? Like, say, I'm developing video applications. Aside from spreading awareness, like, can I be active just by running a node or whatever, or is it something that needs to go into an ISP, and I could just tell my ISP, "Hey, I need this to be there."
Well, you can help yourself by installing an SQM-enabled router. You can help by telling your ISPs to go fix theirs for everybody else that doesn't have those kind of technical chops. So it still is a matter of the technology's there, just have to get people that understand how much better the internet could be, which is why I do these podcasts. It's so great to be on your show again.
Well, I mean, great to have you around here. Cool. So yeah, go look at the project LibreQoS, and it's libreqos.org, right?
No, it's not IO.
IO. Oh, even better. Like it's some other. You can also just find it on GitHub. It's just LibreQoS on GitHub, and yeah, there you have a Matrix chat too, right? So there's a lot.
That's been the most amazing thing for me. I'm an old emailer. The Matrix channel chat has become our principal interface to the world. There are 60 plus really clued and wonderful people in there from all walks of life, not just ISPs, but Rust developers and a whole bunch of people in the Linux kernel world. We've got this great intersection of people hanging out there. It's been one of the most fun projects I've had in a while. Seeing, like yesterday, was 300 plus messages going by about stuff I didn't understand, but it was great to see people talking to each other. So please join us on the Matrix.
Yeah, well, I've used Matrix for a long time. I am on a few open source projects channels, and I will say that, yeah, that Matrix structure that it's not quite Discord, it's not quite Slack. It's a different type of service, and it's really useful. Well, you know where you should come and present this? You should come next year at FOSDEM, or join us at ClueCon. Let me send in a paper for ClueCon. ClueCon is going to be in August from the 14th to the 17th in Chicago, and well, it's my favorite conference, and my second favorite is FOSDEM in Europe in February. So take a look.
I'm personally out of the habit of traveling, but I'm hoping that one or more people will come and talk about finally fixing Bufferbloat for everybody in the world.
Well, then, I mean, I'll be at FOSDEM, so maybe I can go. Oh, look at this! This is awesome.
Again, this show is brought to you by Natasha Silk Art of Half Moon Bay, California.
Well, if you send us a link, we'll add that to the description, together with a link to LibreQoS project, the Bufferbloat project, and all of the other links. And well, thank you, Dave, and thank you, Herbert, for joining us today. It was a pleasure as usual.
Yeah, thank you for having us.
And well, if the launch didn't happen, just go enjoy and talk to
Yeah,
people
well,
and see.
we are basically pool bound. I can think of far worse fates in life to be surrounded by rocket and computer nerds stuck by a pool
And the beach.
and a beach for 2 more days.
That has
So-
to be terrible. I'm really sorry to hear about that.
Yeah. So if anybody out there is bored of podcasts, etc., jump on a plane and come down and hang out and see the world's biggest rocket take off. Hopefully this time.
When are they going to try again? Tomorrow?
Wednesday. Go ahead.
No sooner than Wednesday.
Wednesday.
And watching the weather is what we'll have to do from here. But they can't try to launch on a day-by-day basis because they don't really have enough fuel tanks to do that. So.
Okay.
Yep.
Well, I was watching a documentary on the space shuttle, and the amount of engineering that goes into any of those projects is just mind blowing. Like there's so much. It's really we can do our part. Let's fix the internet. Go download LibreQoS, take a look, go ask your ISPs, and thank you, Dave, and thank you, Herbert, for joining us today.
Thanks. Look, great seeing you.
For the rest of the people, I'll see you next week. Goodbye.
When I was a kid growing up, Buck Rogers always landed tail first. Yet we've never had a landing on the cool green hills. I dreamed of O'Neill Colony and living in the stars. And I thought we'd be in the asteroids and moving on to Mars. We tried Rogello wings and other things, nitrogen tetroxide. All I dreamed was of rockets landing with their engines flaming high. And I was there for Spaceship One's last flights. I saw women and shipped to land. All my dreams restarted then, and I regained hope for man. But we tried shuttle wings, other things, but the costs were way too high. All I dreamed was of rockets landing with their engines flaming high. And I practiced all my landings using Kerbal Space Program as my guide. And smash my bits on autonomous drone ships or crash them on the side. But we just read the instructions laid out before our time, and they're sticking to landings on pad 39. Everybody, we tried Rogello wings and other things, nitrogen tetroxide. All I dreamed was of rockets landing and then running on the side. We tried Rogello wings and other things, nitrogen tetroxide. All I dreamed was of rockets landing with their engines flaming high.